Hello. Okay, let me see. Put a comment in the live chat. I'll see you. Wow. Hello. What? Say something in the live chat. I'm just trying to experiment. Like, how can I go live on YouTube? Right? And maybe I'll try to solve some problems of my subject. So that, I can build some confidence and eventually I can. Actually, you can. Okay, but I can't show the chat in the live. Hmm. But okay, so I will teach you how to solve our data structures and algorithms problem. Uh, would you be interested? Okay. So I'll open the problem. This is the problem that we are going to solve, which is called house robber. Well, well, I guess there must be an option to minimize the YouTube window and just chat on WhatsApp. On Android there is, I don't know. Like if you have this option in your phone, like just go in your recents and then minimize this YouTube tab and just keep chatting, or split window, something of that sort, I can guess. But what? Sorry, I don't. What do you mean no shameful? Okay, so oh damn, you don't have the how do you not have the YouTube app? Is it even possible? Okay, it's iOS, so like on Android you have it by default. That's a hmm. Okay, fine. I mean, what can I say now? I would have loved you to join me in my live stream. So, you know what? Like, if you may want to or enjoy doing it, so you can just like close the chat and you can just open the stream and text me there in the live chat, right? Is that possible? Damn. You can, yeah. You can download it. So do download it. Until then, I'll just make the setup for the problem. Yeah. So first I'm just taking the input, then I'll read the question. Hmm. What the fuck? Okay. So we have the array with us. Now the question is, I'm given an array A of length n where ai represents the amount of money in the ith house. Okay. So the first index or the 0th index represents the money stored in the first house. The second index, and so on. Like each index, the value that's stored represents the amount of money that is there in that house, right? I want to maximize the total amount of money I can rob. Okay, so I want to maximize the total, sum of the subset that I'm going to rob from the array, right? However, you cannot rob two adjacent houses, and doing so will trigger an alarm. So I cannot take any two adjacent elements from the array. If I have taken an element, I can only take the element next to the next of that element, and so on, but not the immediate adjacent element, nor from the left or right. So my task is to compute the maximum amount of money I can rob. Okay, so what I'll do is so we will apply recursion to this. I want to know the maximum amount of money I can rob, right? So let's assume if there were only one house, the maximum amount of money that I could rob was the amount that exists in that house, right? If there were two houses, I would just rob the one with the most amount. If there are three houses, then I have to see if the middle house has more money than the first and three combined. If that's the case, then I'll take the second house. Otherwise, I'll take the first and third house. So how do I apply recursion to this is, so there is an option. Either I can take money from a house, I will iterate over the houses, and either I take a house or either don't take a house. These two options, there are the two options that I have. And then we'll apply the condition that if I have taken money from a house, I cannot take from the adjacent house from that, right? So this will create a lot of subsets of all the houses I can rob, and it will give me, the function will return me the maximum amount of money I can rob through that path, right? So I'm on a house I, let's say, and I'll decide either I take it or not take it. So if I take it, it'll create a set of houses, and if I don't take it, it'll also create a set of another houses, and then it'll return me the maximum amount of money I can rob with those two options, and then I'll return the maximum of those two options to the previous path. That's how this problem has to be solved, right? So we'll do so we'll begin from the index 0, we'll go until n, and we'll pass the array. There must be some other parameter that has to be passed. We'll see about. So the current sum of money, something like that. Let's see if that is required. This will be of integer type, f int index, int n, and int array. So first we'll take the first house, right? Let's say answer 1 equal to f of no, I don't think it's because of that, but just talk to me in the chat, it's better that way. I mean, yep. I mean, that's what I've always wanted. Like, I wanted, I wanted to be a professor. Like, not actually a professor, but uh, be like a professor. Like, be so knowledgeable, and and to know how to behave with students and all that. So it's quite a good compliment for me. Thank you for telling me that. So the first option is I rob the house. If I rob the house, the maximum amount I can rob is the amount in that home, plus if I cannot go to index plus 1, I'll go to index plus 2. That's all, I guess. And then if I don't rob this house, then I won't get the money also, so we won't add the array of index, and then we'll index plus, we'll go to the next house and just apply this stuff. Oh damn. And then return the maximum of these. Okay, Carla, do you understand something from this? I don't think you do. Like, it's like it's weird, I know. If if I reach the end of the array, the maximum profit I can gain further from those is like 0, so we'll return 0. Alright, now it's just almost correct. We're almost done with this. Let's try to run it. Let's see. Okay, so the test case has passed. the next step is to apply dynamic programming to this. So I'll create a DP array int fa int DP. We'll determine the size of the DP. So it must be, the index can go up to 10 to the power 6, right? So 1 2 3 4 5 and I'm 1. That's it. I'll set each of the value, each of the index of the DP array to -1. Wanna join? Wanna join? It would be great if you could join, like on a Google Meet. That would be so fun. What do I have to do there? DP idx equals this. If DP idx not equals -1, return DP idx. Well, it's fine. Even I wouldn't be allowed to talk this loud, if I were at home. But here, I have the liberty of, sitting in the classroom in the night and doing a YouTube live stream. I think I'm done with this problem, I guess. Yeah. It was quite simple. Now we'll see how simple is this when I submit the code. House robber 1. So I'm solving these problems because tomorrow there is a contest. Not tomorrow, just today itself. Okay, so the solution has been accepted. Like, do you kind of get anything I'm talking about in the video? So I have to yeah yeah, it was a problem statement uh, about, like, if you are allowed to rob only adjacent houses, right? If you sorry, I'm wrong. uh, so there are, let's say, many houses, but if a robber uh, steals from two adjacent houses, he would, like, the police would be called, and there will be alarms. So you are not allowed to rob from two adjacent houses. You can rob from one house and another house, from wherever, but must not be adjacent. And all those houses different amount of money. So I have to figure out what's the best path. What's the best. Uh, what are the houses that I must choose to rob from? Let's say I'm giving a number n houses, so that I can, get maximum amount of money. That is the question, and that I have to solve in like programming language. House robber 2. Now we will solve the house robber 2. So this must be more complex. Okay, on OBS. Sorry. Now you must be able to see the screen. Okay. Was the screen not visible at all? Deep is right. Okay, so I've solved the house robber 1 problem, then I'll move on to house robber 2. Let's read the problem. Uh, okay, I remember this has a lot of stuff going around with this. So the twist in this problem is it's the same problem as before. It's just that the house are in a circle. So if I've robbed the first house, I cannot rob the last house because it would be adjacent to it. So for this we did something, but I did not solve that problem at that time, so I might be stuck at some point. But let's try how this goes. So firstly I'll just copy paste the code of the previous problem, right? Now I have to apply the condition that if I have I cannot take the adjacent, so that therefore I'm going to index plus 2. But if this index plus 2 is like equal to n, then I cannot take that, right? So okay, I remember we did something like we created some sort of boolean, uh, is taken or kind of sort of that thing. Let's let's do is taken equal to false, right? We pass it is taken, we pass it here in boolean is taken, and here also I don't know if that's correct, but I know I'm going to the right direction. Something like this has to be done. Is taken, fine. eh. And did you play like paddle there? You told me yesterday, right? House robber 2 is taken, right? Is taken. Now how do I change this value? So initially I have declared it as false, that is not taken. Now if I am like answer 1, which is should I pass true here? Like what should I pass here? False. Here I'll pass true. I don't know, like this isn't working out as a strategy, because let's say you don't take the first index, right? Then we go to the second index, then it'll pass is taken as true, right? That'd be disastrous. We don't have to do that. We What do we have to do? How do I make use of this as taken variable? So what you have to do is just when I take the first index, like okay, can I do something like if index equal to 0 and pass true, else pass false? Can I do this? What if I do this, what would happen? So in 0th index the two true will be gone in that function, but then it would turn to false, right? Fuck, what am I missing? Where am I going wrong? Should I actually let me I can just do this, right? Hmm. This is not the way. Is this the way? I do not know. I'm on my own now. I should zoom in a little bit. So that it's visible on the screen. If I've taken the first index, don't take the last index. Okay, let's say if I I'm confused. Like, how do I do this? Losing the hope. Hmm, 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 hmm. First, we go at the first index. Either take it or not take it. If we don't take it, is taken as false. If we take it, is taken as true. Let's say I don't take the first thing, so it's taken as false. But then I take the next element, so it's taken would be true. That shouldn't happen, right? It shouldn't become true if it was false. So this, it wouldn't happen in this case. It wouldn't become true because index isn't 0, right? But then the problem here is that well, I can just well what I have to make sure is when I'm on the first index, I store this value that is taken as true, and then that value is not changed throughout the traversal or recursion, right? And if I have not taken it on the first index, it just goes as it is, right? It shouldn't change. At the first time I take it, bro, is taken equals true. ah, hmm. Let's read the question again. Should I? Hmm. So at first moment this must be true, this must be false, and if we have passed this thing, it must not change. Oh damn. Wow. So if index is 0, return true, otherwise take whatever value is there already. Wow, if that works, that's amazing. Like, wow, it can work, maybe. Now, now what we have to do is, so this value, if we have taken it true, would always be true, right? And then eventually when we reach n, if index is greater than equal to n, return 0. We also do have to do one thing, like if index is equal to n minus 1, right, we don't have to take the last element. So don't take the last element. Can I just do this, that can I apply this check that we can take it is taken true, and idx equal to n minus 1, then do what? Then don't take it. Then just zero. If this is false, not taken. Now I just feel this should just work, I guess. Let's see. Okay, it has passed. Let's say, what if I don't apply this condition? What then? Okay, let's apply dp to this and then let's see. Okay, dp is already applied. What are the constraints in this? It can go up to 10 to the power 6. So yeah, we have done that. So let's try submitting this. If it works, I would feel proud of myself. If it doesn't, I will debug further, but it would be hard to debug because maybe instead of 0 we could give like int min or something like that. Wrong answer on test 9. Okay, at least we passed the 8 test. If I give -1 instead of 0, let's try submitting that, because okay, it again gives the same wrong answer on test case 9. Why is it giving it? So there's something right with the question, but there's something wrong too. What am I doing wrong? What am I doing wrong? Why truth first bar? Is it because of some sort of int long type of shit? Or is it because of base case condition? Can you just put this in base case? Like, can I just do this? Is it the same thing? It shouldn't be -1. Okay, I'm not able to find out what might be wrong with this. Bro, what kind of test case is this? I need better test cases. House robber to from 0 to F9. How do I figure out this bug? Everything seems to be perfect. It goes from 1 to 10 to the power 6 index. Right. I want to find out the maximum amount that I can rob. It's the same as the previous problem. What the extra thing that I'm doing is, if I take it on the first time, I'm passing the same value again until it reaches until the index v reaches n minus 1, right? Then I have to check if we had taken it. I cannot take it. So am I doing this, executing this correctly? So if you had not taken the first thing, then you could try taking this. Then you cannot take it. I don't know what's the problem. I mean, I would just have to ask like AI. I'll try submitting this once again if that makes a difference. Same problem. Wrong answer on test case 9. What is this test case 9? I have to look at the constraints closely. Let's say n is 1. Okay, let's say if the first element is also the last element. So I've taken the first element, right? Is taken by default is false. And index, so the first time we can take it, like if in the first index I will take it and then call this, and this will return 0. It shouldn't be a problem, right? Comes true for the, I guess it must not be a problem, right? If there is only one n, we just take it, right? Is that what we are doing? Initially it's not taken, so we'll take it and find the maximum answer of that. I guess this logic is correct, actually. Okay, should I just, okay, I'll ask AI what might be wrong here. What give me an edge case where my code might fail. So I have asked Codex to give me an edge case where this might fail, right? For n equals 1, this must be fine. For n equals 2, it says DP index ignores is taken. What does that mean by that? The failure comes from memoizing only by index. Okay. It says, alright, so there is one variable, there is not only index that is changing, there is only the boolean, there is the boolean also that is changing. So I have to make a 2D DP, right? I get it now. 50001. The code returns 0, but the correct answer is 1 by robbing only the last rows. I don't take it. You memorize only with DP index, but the result also depends on is taken. So becomes 0. And later gets incorrectly used for which should be 1. Okay, I get where it's coming from if I apply that logic of changing variables and change this, but I just don't feel that I intuitively do understand. So it's saying f of 4 true becomes 0 right if I've taken it and at index 4 it becomes 0 and then dp index. So we are storing all possible answers for all possible inputs. So index is changing its taken is changing its rate. All right, so we'll make an 3. How much size should it have? Either 1 or 0. So 1 is -1. Legit, like I wouldn't have figured out like by myself. This was a legit thing that I've learned. Try to prosper, burn me slowly. Now this will be submitted. Okay, so as you guys saw that after all the things that I did, there was a little bit of bug or error that I was stuck on, that I took the help of AI to understand that bug and to resolve it. So I asked AI, give me an edge case where my code might fail, and it gave me an edge case where I'm going at index 1, going at index 2, I'm going at all the indexes, right? Index 5. So there could be at each index there could be multiple cases, right? At each index it is taken could be something like different value, and the answer for them is different, but whatever is first stored is stored, right? So you cannot access both the answers. Therefore, for each index that I reach, I have to have two answers, different answers, for depending on the state of is taken. So I get it now. Accepted. So I have solved 95% of the problems. Two problems only are left. Should I solve those also? Live stream is too long, so I should stop the live stream and do those problems just by myself. I'm stopping the live stream for now.